So we've talked about zeros, where the numerator is equal to 0. Talked about vertical asymptotes when the denominator is equal to 0. And now we're going to talk about horizontal asymptotes when it's written in this form of the two polynomials. And they talk about it using words and symbols for the polynomial functions, but I think that when I wrote it on here, I wrote it, hopefully it's a little bit clearer. I even put the letters in bold or words in bold. So if you have this out, okay, the last part about this down on the bottom, the very last section that says horizontal asymptotes is what I'm going to talk about. Now on here it talks about the degree of P and of Q. Well, P is this, the numerator, refers to the numerator. Q refers to the denominator. So when the degree of the numerator and the degree of the denominator. So the ones we've just got done looking at, in those cases, the degree of the numerator was greater than the degree of the denominator. So if we go back and look at each one of them, for numbers 8, 9, and 10, notice that the degree of the numerator was 2. The degree of the denominator is 1 in each one of those problems. And so each of those instances, if we ended up with an asymptote that actually is a line, but what you're going to say is there is none. Okay? In those cases, there's no asymptote. So this would have been the very last one on here. Says there's none for horizontal asymptotes if the degree of the numerator is larger. Okay? And if it's 1 larger in this case or 2 larger, those are specific things that we'll talk about when we get more advanced stuff. So if the degree of the numerator is larger than the degree of the denominator, there's no horizontal asymptote. If the degree of the numerator is smaller than the degree of the denominator, then the asymptote is the line y equals 0. In other words, the x-axis is the asymptote, the horizontal asymptote. And if the degrees are the same, then the horizontal asymptote is y equals the leading coefficients, the ratio of the leading coefficients then. And I'll explain that a little bit more. In some instances, they talk about end behavior with this also. Well, in that case, we're talking about when the values of x, or the absolute value of x, is really large. In other words, we're talking about what happens when x is really, really big down here, or what happens when it's really small down here. Okay, so really big numbers and really small numbers. So here's what happens. All right, so let's go through this problem here, and I'm going to explain why it is what it is. Okay, and it's when we talk about end behavior or the horizontal asymptotes, if you can see this, then it will really help you. All right, so we've got x squared minus 3x minus 4 over x. So first we want to find the zeros. So we're going to factor. So where are the zeros for this problem? Okay, -1 and +4. Okay. Where's the denominator equal to 0 at? Cody? 1. What makes x equal to 0? When it's what number? 0. Okay. So my vertical asymptotes here are x equals 0. Now, for the horizontal asymptotes then, all I need to do is look at the degree of the numerator and the degree of the denominator. In this case, the degree of the numerator is 2, the degree of the denominator is 1. So the degree of the numerator is larger than the denominator. So in this case, there is none. All right, and I'm going to end up with a graph similar to the graphs that we just did in numbers 8, 9, and 10. But I want you to understand why. So if we talk about really, really, really large values of x, okay, like 1,000, okay, if I put 1,000 in there for x, okay, I would have 1,000 squared minus 3 times 1,000 minus 4 over 1,000. Okay. So think about this for a second. Okay. How much does that minus 4 affect the relationship there when we're talking about really, really, really big numbers then, in this case? There's not much effect there, is there? Because we're talking about if I square 1,000, I get 1,000,000, right? Okay. If I subtract 4 from 1,000,000, are you going to be disappointed if you have $1 million and somebody takes $4 away from you? Are you really going to care? No. Okay? 3 times 1,000 is 3,000. Are you going to care if you have $1 million if somebody takes $3,000 from you? Really? You have 999,000, or it's close to that, okay? $997,000, and you're really going to care if somebody had $3,000, okay? Okay, but would it really affect how you're feeling about yourself then? No, not really, okay? So in reality, these two really don't affect that, do they? Okay. So think about it this way then. So if I'm just talking about my variables then, if these two have no effect, so I cross them out, I now have x squared over x. What does x squared over x simplify to? What's x squared divided by x? X. Okay. This is just a line x. Well, when we talk about horizontal asymptotes, like I was saying over here, okay, reminding you that on this problem here, that this was a situation where the degree of the numerator is 1 larger, so that would have been the asymptote there. But is that horizontal? No. So there is no horizontal asymptotes in that case, and it's because if I really think about large values of x, if I simplify this according to the degree, it simplifies to x, which is not a horizontal line. Okay, it's not y. It's y equals x, which is a diagonal line. Okay? It might make more sense when we do the other ones. Okay? But since the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptotes. So graphing it then, we graph our zeros, -1 and 4. Your vertical asymptote at 0. And then we graph it. And in this case, excuse me, your graph's going to look very similar to the ones you were doing in the last lesson. Okay? You graph it, put in your y equals, you'll find some more specific values to make sure you're more exact. But the graph's going to look something similar to that. Okay? So if the degree of the numerator is larger, you have no horizontal asymptotes. Letter B. Okay? Where's the numerator equal to 0 here? At 2. So we have our zeros. There's 1 0 and it's at 2. Vertical asymptotes, where the denominator is equal to 0. Now if I factor this, we actually have 2 denominators in this case, or 2 factors. So what makes the denominator equal to 0? Okay, plus or minus 1. So our vertical asymptotes, there's 2 of them. X equals plus or minus 1. Horizontal asymptotes. All right. So I look at my sheet. All right. Look at the degrees. In this case, the degree of the numerator is 1. The degree of the denominator is 2. So the degree of the denominator is larger. And if the degree of the denominator is larger, it's y equals 0. So if we use that, excuse me, if we talk about the degree of the numerator and denominator and compare them. So if I put in 1,000, am I really going to care about that minus 2 and that minus 1? No, they're not going to make much difference. Okay? So what happens when I simplify x over x squared? What do we get then? A half of x? I don't even see a half there. Okay. All right. Well, we get an x, but where's the x at? Denominator. So I have 1 in the numerator, right? Okay. So think about it this way. All right. What happens as the value of x gets bigger and bigger and bigger? Okay. So if I have So if I have 1/10, 1 over 100, 1 over 1,000, 1 over 1,000,000, okay? What's happening to that number all the time? Okay, it's getting smaller, but it's getting closer and closer to what number? Okay, 0. So y equals 0. There's our horizontal asymptote. So I graph it. I have a 0 at 2. Now I have 2 asymptotes in this case, at 1 and at -1. Okay, so I'll graph them. So how many sections do I have to this graph? Okay. There's 3 sections, right? To the very far left of the asymptotes, between the asymptotes, and to the right of the asymptotes. Okay. And so I'm going to have 3 parts to my graph. Well, I have 1 0 here at 2. That helps me a little bit. Okay. And what's the y-intercept in this case? What's the y-intercept?
2.
And how'd you get 2, Evan?
Put 0 in for x.
Okay, put 0 in for x, you get -2 over -1, which is 2. So we have a y-intercept of 2. So here's what's going to happen, right? Is that because my y-intercept is 2 and the graph doesn't go through the x-axis, the graph has to exist only up here. Okay? Otherwise, there'd be a 0 in here, right? Okay. And since it went to positive infinity on the right-hand side of this asymptote, that means when I go to the left side of it, it has to go to where? Negative infinity. So the graph here is going to look like this. approximately. And since it goes to positive infinity on the left-hand side of this asymptote, when I cross over it, it has to be at negative infinity. So this is an unusual graph, right? It's going to look like this. And I forgot to draw in one thing. What did I forget? Not that. But I forgot the horizontal asymptote here at 0. Okay. So understand this then, okay? And you're going to put it in your calculator just a second. But because I have a 0 here, yes, the graph can pass through the horizontal asymptote. But what happens, it'll go through it, but it has to come back down because as I get bigger and bigger down here, this graph has got to get closer and closer to 0. So it might go through it, but it's got to come back to it. So let's put this in our y equals and see if I'm actually somewhat right. Most of the time I am, not always. All right, make sure when you graph these, the numerator has to be in parentheses. And the denominator has to be in parentheses. Okay, if you got an 83, it's going to connect them. All right, unfortunately, you just have to ignore that where that happens, okay? Because even if you hit trace and type in 1, it's still not going to give you any value here, even though it connects them. Unfortunately, that's one of the technology errors that the 83s have. Okay? But notice, okay, so we look at the graph, all right, comes from the left, goes down to negative infinity, all right, in the middle comes down to 2, goes back up. On the right-hand side of 1, it comes up, but I can't see it there, and the reason is because when I get past 1, these numbers are really, really small. So if I put in 1.5 here, notice it, okay, it's still negative there, because the 0 was at 2. If I put in 2.5, you can see that it's a positive number here, it's just really small. So in reality, my graph accentuates that a little bit just so I can see it. But the truth is that it's really, really close to the x-axis, but it doesn't touch it. But the thing is it goes from negative values at 1.5 to, as I trace along that, at 2 it's 0, but once I get past 2, then these numbers are positive. But if you notice that as I keep going, they're going to get, for a little while, they'll go up, all right, but then they'll start coming back down again. But you see the largest it was about 0.125, so it doesn't get up very high. All right, but if I went to really large values in my table even, you can see it's getting close, coming back down, getting closer and closer to 0. But it will never cross the x-axis again because there's no more zeros. There's only that once. All right, there's one other type, and I'm just going to talk about this one. We're not actually going to do this graph because I want to go on and do the other part. All right, so let's look at letter C here on the check it out. And I'm only going to talk about the horizontal asymptote here. That's all I'm going to talk about with this problem, just to let you see one other sample. So here in this problem for the horizontal asymptote, the degree of the numerator is 2, the degree of the denominator is 2. Okay? So if we ignore all this other stuff here, okay, if we focus on them, what does 3x squared over x squared simplify to? 3. So my horizontal asymptote there would be 3. So if the degree of the numerator and the degree of the denominator are the same, it's the ratio of leading coefficients. Okay? 3 over 1. So to find the horizontal asymptote, you can just look at the first term of each one and simplify that fraction. What do you get? Okay. If you get x, like we did in this case, then you say there's none. If x is in the denominator, then it's 0, y equals 0. And if they're the same here, it's whatever that fraction is when you simplify it, okay, for the horizontal asymptotes. Last thing. Sometimes when you factor, you might end up with a common factor in the numerator and the denominator. Well, what can you do when you have a common factor? What do we normally do when we have a common factor in the numerator and denominator? Okay, you cancel it out, right? Okay. Well, what happens with rational functions is that creates a hole in your graph, because that factor in the numerator gives you a 0. That factor in the denominator gives you a vertical asymptote, and you can't have both of those things happening at the same time. So if you have a common factor in the numerator and the denominator, where that common factor is, the 0 for that common factor is where there's a hole in your graph. So we're going to, first thing we're always going to do, factor. What do I get when I factor x squared minus 9? Okay, x plus 3 and x minus 3. So in this case, I have a common factor of x minus 3 in the numerator and the denominator. So according to what we've talked about before, this means I have a 0 at positive 3 because it's 0 in the numerator, but it also means I have a vertical asymptote, and you can't have both of them. So what's going to happen here is we have a hole at positive 3. So if I simplify that, all right, I cross them out, what am I left with? X plus 3, okay? So we have f of x equals x plus 3. Right? What's the graph of that? That's a line, right? With a slope of 1 and a y-intercept of 3. Okay? So we have this line. But the problem is there's a hole when x equals 3. So on my graph, there's actually, that point's not going to be there. There's going to be a hole there, and the graph's going to do this. Okay. So put that in your y equals x squared minus 9 over x minus 3 and graph it. Okay? It's just a line, isn't it? Okay, but we said there's a hole when x equals 3, didn't we? Okay. So if I hit trace, type in 3 and hit enter, I get no answer. Okay, there's no y value there. If I look at my table where x equals 3, there's an error. Can't divide by 0, so there has to be an error. Okay. But let's look at the graph a little closer. I'm going to focus in on where x equals 3. So I'm going to change my window here to go from 2 to 4 for my x's. Okay. So I'm focused in right around 3. And now look at the graph. Follow the graph. All right, what do you see? Okay, there's a missing pixel there, right? Okay, because there's a hole when x equals 3. The graph goes up to there, okay, and then keeps going. It's just like when you graphed inequalities, right? And the point doesn't exist, you always have to start with a hole there, right? With a circle with an open dot, or an open dot, and then you draw your line. Same thing, that open dot is here, okay, because it doesn't exist there. So the last thing is then, all right, if you have a common factor in the numerator and denominator, then you have a hole. And I could cancel them out, and my graph is what would be remaining then from that simplified.